Welcome back for day 2 of notes while I'm gone. Section 2.6, we will now be proving statements about angles, so back to our favorite proofs. These might be a little bit easier now that you have seen a proof with segment or with segments, and we did a lot of stuff with vertical angles and angle addition before this chapter, so hopefully it's somewhere back in your brains. So we've been talking a lot about these reflexive, symmetric, and transitive properties for segments. Now we're going to equate them to angles. So for any angle A, if we want to use the reflexive property, angle A is just going to be congruent to itself, angle A. Again, reflexive property is where you have the same thing on both sides of the equal sign, or in this case, the congruency sign. Symmetric, if angle B is symmetric to angle A, I said that backwards, so if angle A is congruent to angle B, then angle B will be congruent to angle A. That's what I was trying to say. So this with the symmetric property, they just switch sides. So if A comes first over here, then B can come first over here, and they are still congruent. The transitive property, if A is congruent to B, and if angle B is congruent to C, then you can cut out the middleman and say that angle A is congruent to angle C. And we will be using these with alongside of properties that we know about, supplementary and perpendicular angles to help prove things right or solve different equations. Down here, this is actually an example of a paragraph proof. And I'm going to zoom in real quick. This is an example of a paragraph proof, and it does involve some of these properties that we used up here. But like the proofs from yesterday, they have a given, and they tell us what they want us to show or explain. So in this diagram at the right, angle 1 is congruent to angle 5. I'm going to use little markers. Angle 1 is congruent to 5. And angle 5 is congruent to 3. So we know that these two are equal. And we also know that angle 1 is 103 degrees. And what is the measure of angle 3? You guys might already know that angle 1 and angle 3 are vertical angles, and therefore they're equal, but they're going to go about this in a little bit different way. Let's see, they say because angle 1 is congruent to angle 5 and angle 5 is congruent to 3, using the transitive property, we can conclude, again, get rid of the middleman, that's what the transitive property is, that angle 1 is going to be congruent to angle 3. Because of that, the measure of angle 3 is going to equal the measure of angle 1, and that measure is 103 degrees. Therefore, angle 3 is 103 degrees. All right, let's see if we can transition to our checkpoint question. And it says that, and they don't have a picture with it, so you can either draw one or just kind of read through and see if it fits another one of our properties from above. But it says, given that angle 4 is equal to angle 6, I should say congruent, and that 6 is congruent to 8, and the measure of angle 8 is 77, what is the measure of angle 4? Well, using the transitive property, we can conclude that angle 4 is congruent to angle 8. And then angle 8 is equal to 77, which was given. Therefore, angle 4 is going to equal 77. This is kind of like the definition of congruency, but for these purposes, if you can explain through it, then I'm good with that. Okay. On to some more theorems, and these are some that you might be familiar with. So it says all right angles, and right angles are equal to 90 degrees, so then every single right angle will be congruent. That's an E. Theorem 2.4 says if two angles are supplementary to the same angle or congruent angles, then they are congruent. So here it says angle 1 plus angle 2 is equal to 180. And angle 2 plus angle 3 makes 180. Therefore, the measure of angle 1 should be equal or congruent to angle 3. So if this plus this equals 180 and that plus that equals 180, then those two are probably the same. The last theorem says if two angles are complementary to the same angle, or they're congruent to that angle, then those two angles are congruent. So here, if angle 4 plus angle 5 is equal to 90 degrees, and angle 5 plus angle 6 is equal to 90 degrees, that means that 4 and 6 are congruent. So we are going to use these postulates, I guess theorems, to fill in this next proof below. And I'm going to zoom out so we can have the zoom out so that we can have some of the theorems nearby while we do this. So they actually gave us a lot, so that's pretty good. It gives us some headway into doing this. They said that angle 1 and angle 2 are complements, so that means that they add up to get 90 degrees, right? Angle 3 and angle 4 are complements, so those two add up to get 90 degrees. That should be a 90. They also tell us that angle 2 and angle 4 are equal, so they're congruent. So if you kind of look at the two-column proof, what is listed at first is exactly what was given to us, so we can write given for that reason. And then they hop into the whole fact that the measure of angle 1 plus the measure of angle 2 is equal to 90. Well, that's what it means to be complementary. So this is definition of complementary. They also said that the measure of angle 3 plus the measure of angle 4 is 90. So both of these have the same reason. Definition of complement of complementary. I know that the screen's doing something funny over there. I can't seem to get it to go away. All right, so now we need to use the transitive property somehow. Let's see. Here we both have angle 2 and angle 4. Oh, I see the middleman. If you look at this, 90 is in both of these statements. So if angle 1 plus angle 2 is equal to 90 and angle 3 is plus angle 4 is equal to 90, then that means that these two statements are equal to each other. So the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle 3 plus the measure of angle 4. The next part, where it says the measure of angle 2 is equal to the measure of angle 4. This is the version, that congruence version of the angles. So definition of congruence. Here it just takes the statement, puts some m's in there, and then it changes the congruent sign to equality. So this is just definition. This is the version of definition of congruence. After that, we need to maybe do some substitution. So you can either pick angle 2 or angle 4. So since these two are equal, what you can do is go back up to this statement right here, and I'm going to replace the measure of angle 4. I'm going to replace it with the measure of angle 2 because they're equal. The measure of angle 1 plus the measure of angle 2 is now going to equal the measure of angle 3 plus the measure of angle 2. So this got substituted by that. Since angle 2 is on both sides, I'm going to go ahead and subtract it. If you want to show your work, you can do it on this line. I'm just going to hop to the fact that the measure of angle 1 is equal to the measure of angle 3 because you subtracted angle 2 from both sides. After that, It just hops from the measure of angle 1 equaling measure of angle 2 to the congruency statement. And this is, you guessed it, definition of congruence. So there you have it, your first angle proof. On the back, we are going to probably do one more. The next one is actually pretty great because we've already talked about linear pairs and vertical angles. If you guys remember, in the last chapter, we talked about linear pairs are supplementary. Which means that if you were to add these two angles, you would get 180 degrees. Vertical angles are congruent. They're equal to each other. So, for example, angle 4 is, I guess I'm hopping over to this one, angle 4 is going to be equal to angle 2. And angle 1 is going to be congruent to angle 3. So I bet we're going to be using these postulates in the next example. And we actually did something like this last chapter, so hopefully this isn't too new for you. It says in the diagram, angle 3 is a right angle. I'm going to go ahead and label it with that 90-degree box that we have. And we also know that the measure of angle 5 is 57 degrees. What they want us to do is find the measure of angle 1, 2, 3, and 4. You might be able to go at it because you might notice that 2 and 5 are vertical, 2 and 1 are supplementary, and I bet you 4, 5, and 3 are also supplementary. Or, well, I won't get ahead of myself. But, so by the definition of right angle, we know that the measure of angle 3 is 90 degrees. Angle 2 and angle 5, those are vertical angles. They're across from each other, so they are going to be congruent. Therefore, angle 2 is also 57 degrees. Angle 1, oh, I didn't see this. Angle 1 and 5 are supplementary. They form a straight line. So what you could do, so that means that they are a linear pair. So that means that the angle 1, or measure of angle 1 plus the measure of angle 5 is going to equal 180. Therefore, you could just subtract 57 from 180. And let's see, I'm just going to do that off to the side. Sometimes they get caught up in what all these blanks end up being, even though it's easy to find the answer. And 180 minus 57 is 123. Angle 4 and angle 5, let's see, I'm going to write that in there, 123. And this is 57. Angle 4 and angle 5, I know that I said that all three of these are supplementary, but if you think about it, angle 4 and angle 5, if this half is 90, then that means that this half of the line also has to be the 90. So therefore, angle 4 and angle 5 are going to be complements. So angle 4 plus angle 5 is going to equal 90, and what you can do off to the side, 90 minus 57 is going to give you angle 4, and 90 minus 57 is 33 degrees. All right, so I have about 2 more minutes here to kind of finish these up. What I don't finish, you can try on your own. But this just asks you to find the measure of angle 1 and 2. This is a straight line, so this is going to be 180. So angle 1 is going to be 180 minus 21. And that is 159. Angle 2 and angle 1 are not quite vertical angles. I know they look like it, but this is not straight with that. So what you could do, angle 2 and this 32-degree angle are also supplementary. So 180 minus 32 is going to give you angle 2. And that is 148. The last set, these are linear pairs, which means that you can add up their angles to get 180. I'm running out of time, so I'll let you know that after you solve, you should get x is equal to 21. And then you can plug it back in to get these two angle amounts. Good luck.